So, welcome to all of you in machine learning using Python programming program. So, we are going to discuss about the intuition and implementation of machine learning algorithm. I am Dr. Manoj Kumar Mishra from Rajiv Gandhi South Campus, Banaras Hindu University. First slide. So, this is a small acknowledgement because I have used several images. So, that is only for the learning purpose. The copyright obviously belongs to the original creators. So, with this acknowledgement, let us start our discussion. Now, we all are familiar with this. So, as a computer science person, generally we used to get a problem from the customer. So, after getting the problem, we try to check its feasibility. And if problem is feasible, means if it is solvable, then the another concern comes that we have to find out the appropriate algorithm, and then we have to implement it via finding out the suitable editor for that. So, here basically we, after understanding the logic of that given program, we write the program into that editor, and then we used to run it right over the some given input. If your program is working well, then it is well and good. If it is not, then again we come back to the editor, we will try to do the required customization, and again we will try to run it iteratively until unless it is not performing well over the given data. Once this is over the data, if it is running well, simply we will try to recheck it over the some more number of inputs. So, that is how generally we used to solve the problem as a computer science person, right. But here the challenge which we used to get is this. Once we get the project idea, it is the happiest moment, but after implementing those idea, after finding the suitable algorithm, once we start implementing those idea, and if the platform and language, if you have not decided well, then the life is not going to be that much easy, because the programming language here play the vital role. So, some of the programming language, if you are going to solve the problem by using a procedural programming language, then sometime it is having a very difficult to implement some of the ideas. So, the selection of programming language actually is very important for solving a number of problems. With this understanding, let us move with this. So, that is our day-to-day life, right. We implement our program, our problem into the by using a suitable algorithm after finding a suitable language. But again, if we get the error altogether at one platform, or we should go to find out the error line by line, that matters a lot. So, into the if I will take some data analysis project for example. So, many times we have to do the things iteratively in ad hoc manner. So, few of the compiler is not very suitable for that regard. So, here the selection of the language is is very important part, which will help you a lot to solve the given problem. So, that is actually we used to face every day. So, after solving each error, we as a computer science people we used to get the happiness. So, that was the thing which was expressed by this image. Now, let us discuss why Python I have selected, because the problem which we have discussed so far, the language, the editors, that is a important step for solving for implementing any problem. Even you have finalized the algorithm. So, Python is having so many beautiful features which make it stronger than other programming language, and due to its different features only, it is wide accepted into the different area like a machine learning, data science and deep learning. Now, the concern why we choose Python over the other programming language. So Python is, as I told you, it is well accepted due to its different features. In the area of machine learning, deep learning, we generally use this Python only. Now Python, unlike R, is not built only for data analysis. It is a general purpose programming language. One of the key design philosophy of Python is code readability, ease of use, and high productivity have made Python very popular. So it has a comprehensive set of core libraries for data analysis and visualization. So around 300 plus libraries are there for solving a different set of problems. Now this Python is basically using the idea of POP and OOPS both. So let us understand about the POP. POP is stand for the procedure oriented programming. So here basically we solve the problem by using the concept of function and procedure. Whereas in OOPS, so again in POP there are several issues are there. To mitigate those issues, OOPS concept came into the picture. So in OOPS, everything we write in terms of object and class. Here it is easier to understand. Here there is the option of reusability. Here we can have a friendly nature. Here we can inherit the existing code. So this all properties make OOPS better than POP in many cases. Now over the period of time, people have thought that this OOPS is not is well accepted. The reason behind it, if you solve a small problem, even for that you have to write a number of piece of code, number of instruction you have to implement, and that is not a good idea. So people have thought that there should be some programming language which should use the concept of both POP and OOPS, and there this Python programming came into the picture. So basically Python is giving you both the flexibility to implement your logic either in POP form or in OOPS form. With this, the additional feature of Python is it derived the useful conclusion from the vast data. Let's say even though you are having a good ERP system, but in many cases we used to fetch the unstructured data. So from the unstructured data to get the insights from that data is not that much easy if you are going to use some POP language. So Python is having a number of libraries for that regard. So this, by using Python, you can easily dive into the data and find out the important gems out of that data. So that makes the Python is having a clear edge over the other existing programming language. Now in field of data analysis also we basically prefer Python. The reason behind it, in data analysis we have to do so many things in iterative process. Lots of things needs to be done in ad hoc manner. So being a interpreted language, it provide a interactive interface. So that is another beautiful feature of Python programming. And with this, one more thing, that is a Python has an amazing ecosystem and it's excellent for developing the prototype quickly. So that that is the reason why Python is well accepted. Now based on the number of questions view on Stack Overflow, Python seems to have gained attention and popularity significantly compared to other language since 2012. So you can clearly see over here. Now that is why we are preferring Python. So that part I have shown you here with the image. So if you want to write your name 100 times in by using a C programming, you may see here number of line of code you are supposed to write. Now same thing I can implement in Python with a single line of code. So that is a beautiful feature of Python, which makes the life easier. Now this is a history of Python. So it is invented by Godot van Rossum. So basically he was working in Monty Python Flying Circus. That was a famous TV show in Netherlands. So from this Monty Python, he took the name of Python and invented this programming language. So it is an open source programming language from the beginning. it is having a several application area. So if you are interested to learn more about Python programming language, so you may directly go to this URL and you can strong your understanding in the area of Python. Now these are the famous IDE, Python IDE, which we are going to be used for implementing our ideas, our algorithm. So these are the famous one. I mean, number of it is a subjective opinion, I mean, to select any one of this, but preferably we are going to be use the Jupyter Notebook, because it is having a several advantage over the other Python IDE. Now this is another beautiful reason why we use the Python programming. The reason is you can easily find out the code partner over here. So there is a huge Python community where you can post your query and number of people will come ahead to help you out to find out your concern, to solve your concern. Now with this, these are the several Python channel where you can go and visit and learn about the Python programming. Let us start our understanding with this. If you want to build a program, let's say you imagine here an example. Imagine I ask you to write a program to scan an image and tell if it is a cat or dog. So if you want to build a program using a traditional programming language, then your program is going to get overly complex. You will have to come up with lots of rules to look for a specific curve, edges and color in image to tell if it is a cat or dog. But if I give you black and white photo, your rule may not work over here which you have designed earlier. They may break. Then you will have to rewrite them, or I might give you a picture of cat and dog with a different angle that you did not predict before. So solving this kind of problem using a traditional programming is going to get overly complex and sometimes impossible. Now to make the matter worse, what if in future I ask you to extend this program such that it support three kind of animal: cat, dog and horse. Then once again we have to rewrite all those rules. That is not gone work. So ML is a technique to solve this kind of problem, and this is how it works. Here we build a model, our engine, and give it lots of data. For example, we give you 1000 or 10,000 of picture of cat and dog. Our model will then find and learn the pattern in input data. So we can give it a new picture of cat that has not been seen before and ask it is a cat or dog or horse, and it will tell us with the certain level of accuracy that the unseen data is cat. So with more input data we give it, the more accurate our model is going to be. So that is a basic example. Now see, this is a quite analogous to the how human being used to learn. So we as a human being also used to learn, I mean we used to categorize the new event based on our previous learning, right? The same thing we are going to be do with the help of machine learning. So here, as we have discussed, lots of data we used to give to our model to find out the pattern among the data, and once we understand, once our model will capture the relationship among the input data, now my model will easily categorize the unseen data based on that relationship, right? So that is a basic idea behind the machine learning modeling. Now as we have learned in software engineering, there is a software development life cycle. Similarly here also we are having a machine learning development life cycle. So there are certain steps which we used to follow every time for implementing end-to-end product. So this idea will begin with the planning, right? So we have to understand the requirement, right? What we want to predict. So accordingly, the next input is the data. That is the important part, how to get this data. So we will try to see some of the URLs I will share with you from where we will have our data. Even though here I want to mention one thing, even though you are having a good ERP system, but many cases we used to not, we are not able to get the structured data in all the cases. So for such kind of data, after gathering the data, the next step will come, that is known as the data preparation. So in this data preparation, basically we do the pre-processing and the EDA part. So basically in these two steps, we just try to find out if there is some sort of outliers or not. If outliers are there, we used to handle those things. We find out there is a missing values or not. If missing values are there, then we find out the imputation, suitable imputation technique, and impute those missing value. Also, we will try to find out the relationship among the input feature, and we will try to see their impact on the corresponding output feature under the EDA analysis. After doing this much, we capture the understanding the relationship among the input and corresponding output features. So after doing this, the next step is to selection of the models. So in machine learning, several algorithms are there for doing a same task. For example, for doing a classification, we are having a number of classification techniques. Like we are having logistic regression, we are having a SVM, we are having a decision tree, we are having a random forest algorithm. Now the concern is when to use which one. So finding a suitable technique itself is a big challenging part. So there are several things, several constraints which we have to consider before selecting any suitable algorithm. For example, we have to see the computation power, we have to see the scalability issue, we have to check the loss function, sometime we have to find out the corresponding, as per the output, we have to find out, figure out the corresponding algorithm. So many things actually we used to focus for finalizing the algorithm. So once we finalize the algorithm, we implement our model. After the implementation, the next step is the evaluation of that model. We try to check the accuracy of that model over here. Once our model is accurate with a certain accuracy, now the next step is that is a development, that is a deployment of that model. Once we deploy it, then after that, over the period of time, we have to optimize our model as well, so that this model will be relevance as per the current input. Now in this data pre-processing, there are actually, we basically do in data preparation, basically we do this feature engineering part. So in this feature engineering, the first step comes, that is a feature transformation. Here in the feature transformation, first thing is as we have discussed, as a missing value imputation. There are basically two ways. Sometimes we only consider the column in which missing value is existing. So that kind of analysis is known as univariate analysis, and sometimes we try to impute the missing value by the help of the nearest column as well. So that is a multivariate imputation technique. So KNN imputer is the example of that. Now the next thing which we perform under the feature transformation is handling the categorical feature. In categorical feature, there are number of techniques we used to opt, kind of one hot encoding, label encoder, that is again based on the categorical data type. So if we are having a nominal categorical data, for example, if I will tell you about the name of states like a UP, MP, Bihar, Karnataka, so there is nothing kind of hierarchy, right? They all are same, they are kind of equal kind of states. So in such kind of cases, we used to go with the one hot encoding. But when you are having a ordinal categorical data, when there is some sort of order, kind of, if I will say the grading of any student, for example, he is excellent or very good or good or he is bad, so there is a hierarchy, right? So in such kind of cases, we used to do the label encoder. Now the third step which we used to perform in feature transformation is outlier detection. So in outlier, basically number of ways are there through which we detect the outlier. One of the technique is shorting, right? So generally outliers are either the lowest part or the upper part, right? They exist in that domain only. So we used to identify the outlier by doing a sorting itself, or we used to plot it. So in plotting also we can understand the relationship of the data set. So there also we can visualize the outlier. So once we visualize the outlier, the next thing comes, that is the how to handle it. So that we will see over the period of time. If outlier are there, then with the different techniques we will try to handle it, right? The another work which we perform under the feature transformation, that is a feature scaling. So in feature scaling we are having a standardization and the normalization. So in the standardization is also called as a Z-score normalization. So geometrically we map our data in the range of mean is equal to 0 and standard deviation is equal to 1 over here. And in normalization, basically number of ways are there in normalization. For example, there is a mean max scaling where we map our distribution in the range of 0 and 1. We are having a mean normalization where we used to map the distribution in a range of minus and 1, and other techniques are also there. For example, max absolute scaling, robust scaling. So we will see it. We will try to understand all this scaling method by taking by handling the different examples. Now after doing this feature transformation, next thing which we used to perform, that is a feature construction. Manually here we create the new feature. For example, in IPL dataset, that is a dataset which we will discuss very soon. So here we know the base price of the player, here we know the auction price of the player. Suppose I want to know who is the player who has got the maximum premium. So basically for understanding about the this information, we have to subtract base price from the auction price. So that will be the premium part. So this sometime we have to find out such kind of new feature to understand to answer the so many queries, right? So such kind of things we used to perform under the feature constructions. Next step, that is a feature selection. Sometime your data is having a number of feature, right? So lots of features are not actually very relevant which will help you to predict the outcome, right? So such kind of feature we have to find out, and we have to only select those features which are really influencing the outcome. Remaining feature we have to remove, right? So this task is actually known as the feature selection. After that we perform this feature extraction. So basically by using a feature extraction, so here actually we use the coding part to find out the new feature. For example, like a PCA, let's say you are having a 5 feature, that is a 5D data. So if you go with the 5D data, then it is very difficult to visualize it. So instead of that, we can map the 5D data into 2D. So if it is in 2D data, then we can visualize such a data set, right? So such kind of things we actually perform in the feature extraction. Now the next thing comes, in this entire machine learning part, the input is the data, right? So we have to train our model with the lots of data. So this data part is very much important. So if you see the definition of data, so that is a factual information used as a basis for the reasoning, discussion and calculation. So I took this part from the Merriam-Webster dictionary. Or you may also say the information in digital form that can be transmitted or processed is the actual data, right? So data may be in a different form. There is a 4 different type of data we are having. First is the numerical data. We can also call it as a quantitative data. So this numerical data can be further divided as discrete and continuous. Let me tell you the example of this both of this. For discrete, for example, let's say you are having an integer or float point number, right? So that is an example of discrete numerical data. For continuous data, let's say I want to measure the rainfall on a given day. So it may be measured like a 15 centimeter, 8 millimeter, 5 micrometer, and it go on like this, right? So this is the kind of continuous data. Now next type of data is the categorical data or qualitative data. So here basically there is a limited value outcome. For example, gender. So gender may be the male or female, or maybe the marital status. It is a limited value outcome. Like marital status, maybe either person may be single or married or unmarried, it may be the divorce, right? So there is a limited value outcomes are there. So they are the kind of the categorical data. The another type of data is the ordinal data. So ordinal data is basically amalgamation of numerical plus categorical data. The another type of data which we have to handle, that is the images, audio or video, right? So these are the different type of data which we are having. Now let me tell you one more thing, that is an example of any ordinal data. So for example, let's say movie rating on a scale of 1 to 5. So obviously if you are saying 1 means that is a worst movie, right? That is a worst movie. If you are scaling it as a 5 simply means that is a excellent movie, right? So ordinal data is basically the amalgamation of numerical and categorical. Now for obtaining the data, we are having several sites from where we can download our data, right? So these are the famous UCI library from where you can download your data and you can use it, right? So the another site which is very important for downloading data is IEEE data port. From here also you can download the data and for our machine learning understanding. This is a famous one. I mean, this is I personally prefer this Kaggle site because it is having other feature as well. So here all the data sets are almost all the data set is available, and it is also having I mean, here itself you can implement your machine learning algorithm. So that option is also available in the Kaggle. So I personally prefer the Kaggle for obtaining the data. Now the next is this COVID-19. That is I mean, the still people are working in this area. So NCBI is the site from where you can get all the COVID related data set for performing your experiment. Now this is a question comes number of times from our student, why we say that we should download the data from certain sites. Why not we can make our own data and we can perform the experiment with that data itself. So what's wrong with that? So if you want to use your own data, then that data set should be I mean, the benchmark you have to make, right? For that regard, the data must be publicly available. We have to upload on the online portal, and without any permission, open access, it should be available for everybody, right? That is the meaning of that. And the data set must address the specific problem and instance, like a classification problem or regression problem or clustering or ensemble or decision tree. Data set should not be generic for all the algorithm. Your data set should not be like an all-rounder, right? So that part we have to always consider. And then third attribute which your data should have, that is a preferably standardized, standard deviation based, consistent variance it should have, or statistically formulation should be used. And the fourth feature which should your data set should have, that is a categorical based, right? So if you want to use your own data, then you have to make your data as a benchmark. So with this feature your data should have, then only you can utilize your data for performing the experiment. Now this is the after the data collection, the main part, after the pre-processing part, the another step comes, that is the modeling of the data, right? The machine learning modeling. Now in the machine learning modeling, this is our full data set which we have collected and the process, we have done the pre-processing of that data. Now this step, over this step actually we try to identify our input and the corresponding output. So this part we used to perform as a first step. So after this categorization of input and output, we divide our data into train test and test set, train set and test test. So here let us say we have divided the entire data set into 80-20 ratio. So this 80% data we will use for the training purpose, training of the modeling, right? With this 20% of data we will use for the testing of our model, right? So with this train X and train Y, we have trained our model. Now this model will capture the relationship between X and Y, right? That is the meaning of that. So basically modeling is nothing but the logic which will identify the relationship between x and y. Once this model has trained, it captured the relationship between x and y. Now with this we used to test our data over this model which we have trained, right. So here we give this test x to this model. Now once we pass this test x to model, it will give us the test y, that is nothing but the predicted outcome. This was the actual outcome, this is the predicted outcome. Now both the value we are having side by side. Now we will compare this, and this will help you to find out the loss function, and based on the loss function we check the accuracy of the model, and we will decide either the model is going to be acceptable or we have to go with some other model technique. So that is a general idea how this machine learning modeling will go. Now these are the important library which will help us for implementing the machine learning logic, machine learning algorithm. So the beautiful part of Python is all these libraries are already pre-installed, right. It is already integrated with the Python, right. So we have to only find out the corresponding library and the corresponding function. So by using it we can implement those things, right. So as I told you, number of libraries are there in Python, for example more than 200 plus, right. So these are the few libraries which is very helpful for us for doing a machine learning work. So famous one is NumPy. So it is a basically numerical Python. So one of the most important package for numerical computing in Python. It consists of multi-dimensional array object and a collection of routine for processing those array. We are having a matplotlib. So it is used to draw the 2D graph and plot which are used for data visualization. You can create a stunning plot like bar plot, scatter plot, histogram and lot more with this library by using the extensive set of plotting APIs. We are having a Seaborn, so it is using a fewer syntax and has a easily interesting default themes. Again it is for the data visualization only. We are having a scikit-learn, that is basically used for a machine learning algorithm. So now with this, from here onwards we are going to be implement our machine learning project. And we will use the environment called Jupyter Notebook for implementing those things. Thank you very much.